Hello, this is Mrs. Sturgeon here to explain how to find the vertex for a quadratic that's either in standard form or in vertex form. So let's go ahead and get started. First, for these 5 problems up at the top here, we're going to talk about what does standard form look like versus what does vertex form look like. So vertex form, what you're going to be looking for is basically you have a set of parentheses. That set of parentheses is squared, and then you have a number that's being either added or subtracted outside of those squared parentheses. So let's talk about, okay, in this list, what would be considered vertex form? So I'm looking at number 2, and the qualifications that I just mentioned, like I said, you've got parentheses, you've got this number outside being added or subtracted, and to be fair, if that number isn't being added or subtracted on the outside, that doesn't necessarily stop it from being in vertex form. Really what you're looking for is this right here, like I said, the parentheses squared. So this is considered vertex form. And then the next one that's in vertex form is number 3. Both of these are in vertex form. So again, if you look for those parentheses, that's going to help you figure out whether it's in vertex form or standard form. So it turns out the rest of these, none of them have those parentheses, so they are all in standard form. Okay, so again, the difference is between whether the equation has the parentheses and whether it does not. So that's how you can decide, am I in standard form or am I in vertex form? Now, let's talk about how to find the vertex regardless of what the form is. Okay, so starting with vertex form. The nice thing about vertex form is that it's actually called vertex form because you can tell what the vertex is without doing any math and just by looking at the equation itself. So if I look at the equation, the 2 numbers that I need to look at to identify the vertex, one of them is right here and the other one is right here. So I'm looking for my number that's inside the parentheses with the x, and then the number that's being added or subtracted outside of the parentheses. Those are the numbers that will give me the vertex of the quadratic function. So x minus 7. The fact that we're subtracting 7 actually means that we're taking our function and we're shifting it to the right, which means that my vertex is actually going to be at a positive 7. So you see a minus sign, but my vertex is at positive 7. So I essentially take the opposite sign. Then I have the minus 1 on the outside of the parentheses. That means that I'm shifting my function down 1 unit. So that means my vertex will be at negative 1. So my vertex for this function is at positive 7 and negative 1. Okay, so for my next problem, this time in the parentheses, I have a plus 2. So again, if I'm thinking take opposite sign, if it's a positive 2, my vertex is actually going to be at negative 2. And then on the outside, I'm shifting down 5, so that will just stay the same sign. So this will still be a negative 5. So basically take the opposite of the number that's in the parentheses, and then the number that's outside the parentheses, you can keep the same sign. All right, so the last problem here. All right, we have negative 2 inside the parentheses. We have positive 10 outside. So again, this would be a positive 2 and a positive 10. Okay, so we take the opposite sign inside the parentheses. Outside the parentheses, the sign stays the same. And that's how you find the vertex in vertex form. Let's talk about how to do it in standard form. In standard form, we require a little bit of math here. So if you look up here, there's a little note. It says negative b over 2a, and then comma, sub back in. So I'm actually going to follow those directions, and I'm going to do negative b over 2a to find the vertex when we're in standard form. First thing you want to do is identify what is a, b, and c. So for a standard form quadratic that looks like this, ax squared plus bx plus c. Identifying a, b, and c, basically look at the number that's in front of the x squared, that's your a. So a is 2. B is going to be negative 16, and C is 31. Oops, sorry, 31. Okay, so from there, we just need to go ahead and substitute those numbers into the formula, so negative b over 2a. Now, negative is part of the formula, so I'm just going to write it automatically. Now, b is a negative 16, so I technically need another negative sign. divided by 2 times a, which is also 2. Okay, so now I need to do the math. So negative and a negative. If I make a negative number negative again, it essentially just turns the number positive. So this is actually just going to be a positive 16 divided by 2 times 2, which is 4. So 16 divided by 4 is 4. Now that's the x number of my vertex. That's why it's located in the first slot of my ordered pair in the note. Okay, now in order to figure out what the y value is, I need to substitute it back into the equation and figure out the math. So it looks like this. Instead of writing x's, I'm going to write 4, because again, I'm going back, plugging it in, seeing what I get, and that's going to be my y value of the vertex. All right, so we can do this by hand. You can use a calculator. It's up to you. If we're doing this by hand, make sure you use order of operations. So 4 squared is what you should do first. 4 squared is 16. So we have 2 times 16, those are parentheses, minus 16 times 4 plus 31. Okay, so now 2 times 16 is 32. And then minus 16 times 4, that's 64, plus 31. Okay, you might need a calculator for some of this. 32 minus 64 is a negative 32. If you add 31 to that, you're going to get negative 1. So my vertex for this problem is 4 comma negative 1. And that's how you find a vertex in standard form.